Today's video is on gas density.
So we are very interested in the density of gases. They're a lot less dense than other states of matter, so we'll have to use a different set of units. Maybe instead of using grams per milliliter, we can use grams per liter as a sensible unit. So there we have grams per liter, a sensible unit for the density of gases. But the question is how to determine the density of a gas. Well, since the gas laws are coming later in our course, for now, let's try to stay at standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere. Okay, so we have density here equal to mass per unit volume. We know that from before. And let's try to use the mass of 1 mole of gas here. That's a sensible mass. And we'll try to use the volume of 1 mole of gas over here too. And of course, we know the volume of 1 mole of gas at standard temperature and pressure is 22.4 liters. Okay, so here we have the density, and it's going to be of a gas at STP. And we'll just divide the top and bottom of this expression both by mole. So mass per mole and volume per mole. And mathematically, this is okay because the mole cancels on the top and the bottom. You know how algebra works. If we multiply top and bottom by the same amount or divide by the same amount, it's all good. So we have density here as mass per mole divided by volume per mole, and then the moles cancel out and we're left with mass per volume, and that's exactly what we were expecting. So here we have it. What is the mass per mole except the molar mass, and the mass or the volume per mole except the molar volume? So that's it. There's the molar mass on the top, and on the bottom we'll have our standard molar volume of 22.4 liters at STP. That's going to be the density of a gas at STP. Well, it's good. It's in units of grams per mole here for the molar mass, liters per mole for the molar volume. Calculate out the thing and you get the correct units. Everything's working out very well indeed. So there's our formula for the density of a gas at STP. So let's see if we can put this to work. And I'd like to make an example here about propane. So we'll have a sample of propane held at STP, and the question will be, what's the density of this sample of propane? So I might remember propane has got 3 carbons on the main chain here, surrounded by all hydrogens all the way around. And of course that's C3H8, known as propane. You find this near barbecue. So the density will be the molar mass divided by the molar volume, as we said. Molar mass of propane is 44 grams per mole, and molar volume at STP, 22.4 liters. Everything works out here unit-wise, and we get the density of propane as 1.96 gram per liter. Okay, let's try another example. We have a gas known to be one of these nitrogen oxides, and we have its density as 3.4 grams per liter. So which oxide is it? So we'll just rearrange our expression here, the density is molar mass per volume, as molar mass equal density times volume, and then just go ahead with our values. And notice, by the way, here, if you watch the liters, will cancel, get grams per mole. So we'll be working out the molar mass now, and the molar mass of this is 76.2 grams. If you look at the list of nitrogen oxides, the dinitrogen trioxide had a mass of 76 grams per mole, so that's likely it. Now, until we get to our unit on the gas laws, the standard molar volume is fixed at 22.4 liters. So until then, other gas density problems will be just variations on the theme of these examples. Anyway, thanks everyone, and see you soon. Please have a look at the next 2 videos in the playlist for more, and stay tuned for our next lesson in Chemistry 11, Lesson 13, Empirical and Molecular Formulas.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe!